Types of quadratic functions. There are three types of quadratic functions. That is, the same function can be written in three different forms. That is the thing. So the first one is the standard form, and then you have factored form, and the third is the vertex form. So let us look at the standard form and what is the use of knowing this standard form of a quadratic function. Is the first and the most important thing is that value of c. C is the y-intercept. That is, when you draw the graph of this function, this graph will intersect the y-axis at a point 0. So anywhere on the y-axis, you know that x is 0 and the value of y is c. So whenever you have to find y-intercept of a quadratic function, the best thing is standard form. If I have standard form, just my constant value is going to be my y-intercept. Okay. Now, the second thing that I get from this is about the stretch or shrink of the quadratic function, of the graph of the function, I should say. When you draw the graph, this graph, whether it is stretching or shrinking, here it is a stretch, and shrink, it will be in this form. So that you will get by knowing the value of a. If the value of a is greater than 1, like 2, 3, 4, if a is equal to, let us say, a is equal to 2. So there is a stretch by a factor of 2. If a is equal to 1/3 or 1/4, then it is a shrink, you will say, right? Alright. So those are the things, and not only that, depending on the value of a, if a value is -3, it will tell me that the graph is reflected over x-axis. It will be in this form. That is, it is opened downwards. The graph of the function will be opened downwards. This is how it will go. If it is a positive value like a equal to 2, then the graph of the function is open upwards. So, what are the things that you understand from the standard form of a quadratic function? First and most important thing is the y-intercept. Then, next thing is about the stretch or shrink depending on the value of a, and depending on the sign. If positive or negative values will tell you about the direction in which the graph is extending, whether it is open upwards or downwards. Okay, that is the first type. Now, second form is the factored form of a quadratic functions. Okay, in this factored form of a quadratic function, the most important thing is that I get to know what are my x-intercepts. So directly from this function, I can say that r1 and r2 are the x-intercepts. That is, the graph of the function will intersect x-axis at r1. See, this is the point. Let me just write r1 and r2. Okay, so those are the x-intercepts. That is the advantage of having the factored form of a quadratic function. Here this is, like I said, this is r1 and that is r2. If we take an example, let me take 2 times x minus 3 times x minus 5. So the value of r1 is 3 and r2 is 5. Here it is 3 and that is 5, just for example. And for that value of 3, what happens to the y value? Anywhere on the x-axis, we are calling it as x-intercept because it is the x-intercept. For x is equal to 3, the value of y is 0 here. And when x is equal to 5, the value of y is 0. These are the things I get. Okay. And adding these two x-intercepts and divide by 2, like 3 plus 5 over 2, that is how much? 8 divided is 4. and that 4 is your axis of symmetry. What do you mean by axis of symmetry? It is the line that passes through the vertex of this graph. And where is the vertex? It is, in this case, it is the minimum point, because the graph is opened upwards. This point is the vertex, and this perpendicular line that is passing through the vertex gives you axis of symmetry. And you know that the axis of symmetry divides the graph into two equal parts. This piece is the reflection of the other one. That's why we use the word symmetry. So, having known the factored form of a quadratic function, my greatest advantage is getting to know the x-intercept. For that value of x, the y becomes a 0. That is the most important thing I learned from this factored form. Of course, you can get axis of symmetry. Using axis of symmetry, you can even find the value of that vertex h comma k. Substitute this value 4 over here, you will get the value of y. Alright. Then the third form is your vertex form of a quadratic function. Okay, so here we have a quadratic function in the vertex form. F of x is equal to a times x minus h whole square plus k. So here the vertex is what? This h comma k. So vertex equal to x coordinate of the vertex is h and the y coordinate of the vertex is k. The coordinates of this point are h comma k, and it will give you the minimum value if the graph is opened upwards, and if the graph is in this direction open downwards, like if the value of a is negative, it goes down. In such case, the vertex is on the top, and that gives you the maximum value. Not only that, we can also find the axis of symmetry, just the x coordinate. What is the value of x here? That is h. So x is equal to h is the axis of symmetry, right? This line. Okay, so the most important thing or the usefulness of knowing the vertex form is getting to know what is the vertex, and then you will be able to identify whether the graph has a maximum value or a minimum value, right? Depending on the shape of your graph. Let me take an example. F of x is equal to 2 times x minus 4 whole square plus 3. So in this, your 2 is a, your h equal to 4 and k is equal to 3. So the vertex v is what? The vertex v is 4 comma 3. 4 comma 3 h comma k, right? hk. And the axis of symmetry is 4. Your h value equal to 4. That is the x coordinate, so you can as well say x is equal to 4 is my axis of symmetry. Okay, so those three are the different forms of quadratic function. Now I hope it clarifies some of your doubts, like standard form helps me to find y-intercept, and something else like mean stretch, shrink, all that. Factored form helps you to find x-intercept and the axis of symmetry. And the third form, the vertex form, will let you find the vertex and the direction, the max value, minimum value, and all that. Okay, thank you.